Welcome to this presentation of the Norwegian use case, and the offshore crane, part of the Arrowhead Tools project. Our team consists of two innovative software companies, Jotun and Telu, as well as two research organizations, Norwegian University of Science and Technology, and University College Østfold. We have jointly developed new and exciting software applications, connecting IoT to the digital twin for condition-based monitoring. Large and complex products such as aircraft, vehicles, oil and gas installations, and ships depend on accurate engineering information for their successful operation and maintenance throughout a life cycle, often measured in decades. By using a common standard, we can eliminate the unnecessary cost of manually converting or re-entering information between different computer systems. The research ship, located in Trondheim, is equipped with the latest technology for a variety of research activities, and our focus is the offshore crane, as you can see in the picture. Your product is built to last for decades. Your data management systems and their formats are probably not. Are all your data management systems communicating with each other? Do you have the means to ensure consistent quality of product data throughout your product's lifecycle? Standards will support you to address these concerns. The Arrowhead approach to interoperability is to establish and use a common unified repository, in which product and process information from many sources, such as systems and companies, can be merged and consolidated. The standard-based repository is designed to handle many product versions and configurations, and to distinguish between information packages received from multiple suppliers and partners delivered to many customers. Organizations of any size achieve high performance by making timely, effective, and efficient decisions. All decisions rely on a fundamental input, the correct information. Using the core components of a typical standard-based digital twin, you will have a future-proof solution. This architecture shows how you can create your applications in days, not in months. All data will end up in the ISO step-compliant repository, complemented by the Arrowhead framework, now available in the open-source Eclipse platform. To create a successful installation of your systems, the principles are quite basic. You will need the 3D or simulation model. Then you will mount the sensors on your product. Finally, you will configure the Arrowhead software. The simplicity of the services and its rich functionality ease up the integration work. With talented programmers, this may be an effort of a couple of days to create a high-performance and low-cost digital twin of your systems. Here you can see the crane dashboard. The main function of the dashboard is to visualize the operations of the crane mounted on the ship. The data is sent from the ship and stored in the cloud. The data is retrieved from the cloud and represented in real time. The dashboard is accessible from any device, as it is a browser-based application. As an example, you can see the 3D model of the crane, as well as a selection of the 8 current active data points, all connected to the ISO-compliant Arrowhead framework. The knuckle boom crane on the ship is instrumented with a number of physical sensors, monitoring the crane motion. The data are processed to eliminate sensor noise, and converted to actuator signals, driving the digital twin model. The physical sensor data are also used by an inverse method for payload detection. The digital twin finite element assembly model, using 3.6 million degrees of freedom, is running faster than the real crane, due to the use of a CMS model reduction technique. This includes the calculation of stress and strain time histories in hot spots identified by a virtual brittle lacquer. Our digital twin model can also calculate and display forces, displacements, hydraulic, and control system variables in the cloud solution. To reduce the amount of data, a trigger event is initiating the digital twin simulation when a critical crane load is detected. In our case, the digital twin is replicating the real crane motion in real time, displaying an unlimited number of virtual sensor outputs in the cloud. Using the standard data model AP209, multidisciplinary analysis and design, we will create freedom from vendor lock-in, addressed by open data solutions. Such data will provide the input to the condition-based monitor application that will interact with the ship operational maintenance systems. This will reduce cost, as well as prolong maintenance periods. Several users are now implementing the solutions all over the world, and the capabilities are endless for newcomers, allowing them to use the results from the revolutionary technology. Systems includes machining equipment, assembly devices, and new educational student projects, like electrical bikes and much more. The Arrowhead framework and ISO specifications supports open, international, and public available standards for engineering, manufacturing, and support data. This will help you to deploy next generation of data exchange, sharing, and archiving solutions. Of these characteristics, the most critical are timeliness, accuracy, completeness, and provenance. Thank you for being interested in our achievements.